All right, freshmen, we are on lesson 6.6 today, but we're going to start the day the same as always, even though I'm not there. Stuck in jury duty today. You're going to start with a quiz 6.5, so grab a sheet of paper. You can pause this video at any time if you need more time, but I want you to write down this system of equations here from 6.5 and then choose the best method to solve it. All right, so pause the video, work on that, turn that thing in, and then come back to the video. Today we're going to be talking about 6.6 systems of inequalities. So we've been talking about systems of equations. Now we're talking about systems of inequalities, if you can guess what that means. We're going to be solving and applying systems of linear equalities. This is the goal of the day. So here we go. First of all, we got to know what is a system of inequalities. So hopefully you guys have your notes for the day. If there's some problem with the notes for the day, I do want you to jot this down either on a sheet of line paper or something else, but make sure you tell me get this down in your notes. What is a system of inequalities? Well, it's a set of two or more inequalities with the same variables. Okay, a set of two or more inequalities with the same variables. We're going to look at a couple of these here in a second. Okay, so you'll see what these look like. But before we do, I want you to learn the steps that are involved with solving inequalities. So first of all, you're going to solve both of the inequalities for y. Okay, so we're going to solve for y first. So you're going to have something that looks like this. Y is greater than, might even be greater than or equal to, maybe 2x plus 2 or something like that. So we're going to solve for y. The other one might be y is less than 3x minus 1. I don't know what it would be, but just solve. We're going to solve both of these things for y. We're going to graph those inequalities. And remember, in order to graph anything that we've been talking about in here, first we're going to start with the y-intercept. Then you're going to use your slope, okay, to make your points. So just a little review here. Your slope is going to be right in front of your x term. Okay, so on the two examples that I gave here, we have a slope of 2 over 1 and a slope of 3 over 1. That means from left to right, they're going in the positive direction, going up from left to right. Okay, so just a review of slope. And if you need to review back to some previous lessons, you can do that. Okay, then step 3, look at the inequality symbol and graph your lines. So symbols that are dotted are symbols that do not have, and this should all be somewhat of a review. If we don't have a line under them, it means that it's not equal to that line, but it's either greater than that line or less than that line. So these symbols have a dotted line when we go to graph them. Okay? So just so that makes sense, my first example up here, if I were to go graph this one here, since it has a line underneath, would have a solid line when I graph it. But my other one, since I do not have a line underneath the inequality, would have a dotted line when I went to graph it. Okay, then for step 4, you're going to shade your graph. If it is less than the inequality, think about it, if it's less than the line, then you're going to shade under the line. But if it is a greater than symbol, you will be shading over the line. Okay? Any overlapping shaded regions should be darker because that is going to be the solution. All right, for example 1b, same thing here. We got to solve for y though first for both of these. So I'm going to solve for y with my first one here. Make sure my pen works. 2x plus y is greater than or equal to 2. I got to get y by itself, so I got to subtract 2x from both sides. So when I do that, I get y is going to be greater than or equal to negative 2x plus 2. There's my first equation. Switching colors here, I'm going to do the other one. 2x plus y is less than 4. So I'm going to solve that guy. So I need to subtract 2x from both sides. Okay, and I get y is less than negative 2x plus 4. So those are my two equations that I'm going to be using. All right, now let's graph these. I'm going to try to keep the colors straight here. So I'm going to graph the first one. So it says y is greater than or equal to negative 2x plus 2. All right, so I'm going to start at the plus 2. That's my y-intercept. And then I know that I'm going down to, my slope is negative 2, so I'm going down 2 over 1. Down 2 over 1. If I'm going backwards, I would be going up 2, back 1. Okay? Now, since this is a or equal to, I'm looking back at my graph there, I know this is going to be a solid line. Not the best line, but it'll do. Okay, for my other one, it is not or equal to, so therefore I'm going to have a dotted line. So y is less than negative 2x plus 4. So I'm going to go up to plus 4. 1, 2, 3, 4. Put a dot there. Okay, this one's going, again, down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. And this is interesting if I would have drawn that other one better. Okay, I'm going to put a dotted line here. Now, if I would have drawn this red line better, which maybe I'm just going to go ahead and do that. Oh no, I've messed it all up. Okay. Back to the red line. You'll see that these are parallel lines. So let's see if there's any kind of overlap here. Okay, so with my red one, it says y is greater than or equal to. So if y is greater than or equal to, I know that I have to go above my line. Okay. So technically, I can go right through that other line. It's everything above that line. All right. And then for my purple one, it says y is less than that line. So technically, all of this. But remember that we're dealing with systems here. Okay? So the system is where there's any overlap, because we're looking at what these two things have in common. All right? That's what a system's all about. What do the two things have in common? Well, what it has in common is everything in between the two lines. That's where the shading happens with both colors. So that's my answer. That's where it should be darker for 1B. Continuing on, example 1C. Notice my first one is already done for me. My second one, I have to solve. So y is going to be, I'm going to subtract 3x from both sides. Okay, so y is going to be less than or equal to negative 3x plus 2. Now, let's go ahead and graph these. I'm going to do this one in red. So it says y is greater than or equal to negative 4. So I'm going to go down to negative 4. 1, 2, 3, 4. Put a point there. It says greater than or equal to, so it's going to be a solid line. Okay, and then my other one is also going to be or equal to, so it's going to be a solid line, but it says y is less than or equal to negative 3x plus 2. So in purple, I'm going to graph that one. We're going to go up to plus 2. That's where we're going to start. Okay, and then we're going to go down 3 over 1, because that is my slope. Down 3 over 1. Okay, this is also going to be a solid line. Try to draw it accurately here. Okay, so now let's do our shading. I always like to get my lines on there first, and then I do my shading. So I'm going to go back to my red equation here. It says y is greater than or equal to negative 4, so it's everything above. Okay, so it includes all of this. And then for my purple equation, it says y is less than this thing. All right, so it's going to be everything that's on the underside of the purple line. Okay, and you'll notice that the place where there's overlap is the place where we have a solution. So I'm going to make sure that's nice and dark where I have my overlap. And that's the answer for 1C. The answer is the darker area that is shaded. Any of those points work with both of those equations. Okay, this one, I think I kind of gave it away at the top there. It says there's no solution. Let's check it though. and make sure that is indeed the case. So this one is y is greater than 3. So I'm going to do that one in red. Y is greater than 3. This one should have a dotted line here because we don't have an or equal to sign. And then it says y is less than 1. Okay, so dotted line here. And I guess I should be doing that one in purple so we can see the difference. Okay, so let's go ahead and shade these. So for the red one, y is greater than 3. Well, it has to be above that line. So it's up in here. And then for the purple one, it says y is less than 1. So it has to be below. So it's down here. So the question here is there any place where there's overlap? Because that's where our solutions happen. The answer is no, so there's no solution here. But you still need to graph it, show it, and then write no solution. Okay, let's look at a real world problem for a minute here. So real world problem. This should be in your notes as well. The theater club is selling shirts. They have only enough supplies to print 120 shirts. They will sell sweatshirts for $22 and t-shirts for $15 with a goal of at least $2,000 in sales. Define the variables and write a system of inequalities to represent this. All right, so this is where your math comes to life in these real-world problems. You can see why you would need to do this. These types of inequalities show up a lot in the business world. So let's take a look at this one. Now, there could be multiple answers for this guy, depending on what you want to use for your variables and all that, because it doesn't tell you what the variable should be. It says you have to define them. So for me, I always look at like key letters that are in here. So I'm looking at sweatshirts and I'm looking at t-shirts. So to me, I would use S for the number of sweatshirts, and I would use T to represent the number of t-shirts. So there, I've defined my variables. I've told everyone in the world that wants to know what S means and what T means. Now I need to write a system of inequalities. So I know that we have only enough supplies to print 120 shirts. Some of them are going to be t-shirts, some sweatshirts, but I don't know how many of each. So I can use my two variables and just say, okay, no matter what, S plus T has to be less than or equal to, because it says we could print 120, up to 120. So that has to be less than or equal to 120. All right, that's the first thing that I need to establish. The second thing is, well, what's the cost of each of these things? So for the sweatshirts, they cost $22. Okay, and I guess I'll do this in purple, keep it kind of consistent here. So we know that 22 times sweatshirts added to, and notice we have $15 for t-shirts, so $15 times t-shirts. And together it says it has to be at least $2,000. Okay, so if I add these together, however many I sell in each one of them, it has to be at least $2,000. Now I have my system of equations. I can graph them once I solve for one of the variables. Okay, in this case, we might want to make our x variable. Well, let's solve for our y variable. Our y variable here is going to be, let's just make our y variable equal to t. Okay, so t, let's solve both of these for t. When I go to do that, I get, in the first case, I get t is less than or equal to negative s plus 120. And for my second one, I'm going to get, I'm going to move my 22s out, so I'm going to get 15t is greater than or equal to negative 22s plus 2,000. But then I need to divide everything by 15. So once I go to do that, I'm going to get I'll just write this over here, I guess. T is greater than or equal to negative 22 over 15. That's just taking negative 22 divided by 15s. Okay, and then adding that to 2,000 divided by 15. Now, I don't know that off the top of my head, so I'm going to have to run that through a calculator here. 2,000 divided by 15 is 133 and a third. Okay, so it's equal to 133 and 1/3. All right, so now I have my two equations. I've solved for y. I have my slope for each one, and I also have my y-intercept. Okay, so the y-intercept for my green guy over here is 120. Now, I'm just going to pick this point up here toward the top and call this 120. I'm going to label it. Okay, and I know from there I'm going down 1 over 1, down 1 over 1, down 1 over 1. Or I can say I'm going down 100 over 100. It's the exact same thing. Down 120 over 120. So I'm going to do that. So 1, 2, 3. I have 4 spots to the origin. So I'm going to go over 4 spots. 1, 2, 3, 4. That gives me my nice slope of 1. And I can draw that in. Okay, notice it's a solid line. And then for my other one, it says that my y-intercept is 133 and a third. So I'm just going to put that up here, just above that a little ways. And it says that it's sloping down at negative 22 fifteenths. Well, if I divide that out, that's like kind of sloping down at negative 1, close to negative 1.5 or so. So interesting with this, what's interesting with this piece is on this large of a scale, it's a little bit hard to graph. And actually, what I would say now looking at it, just because the scale is so big, the better way to do this would actually be to throw these equations that you created into Desmos. So I'm just going to show you that real quick, because if it gets to be something that's this ridiculous, you should probably use a graphing tool. And I know that you guys don't have graphing calculators. So I'm going to switch this over to Desmos. Let me just jot down these equations. So what I'm doing is I'm jotting down my equations. I'm going to say, instead of t, I have to change it to y, though. So y is less than or equal to negative s plus 120. Jotting that one down, and then I'm jotting my other one down. Y is greater than or equal to negative 22 over 15s plus 133 and a third. Now, I'm going to click out of this for a second. Head over to Desmos. There we go. Let's see if it lets me do this. Y is less than or equal to negative x plus, notice how they shade that nicely for us. I'll have to change our scale here in a second. Y is also greater than or equal to negative 22 divided by 15x, and I don't want it like that. There we go. Okay, plus 133 and a third, which is actually the same thing as, I'm going to write it the other way, 2,000 divided by 15. Okay, now I just need to zoom out a little ways, so I guess what I'll do is I'll just zoom this out if it'll let me. No! Okay, I'm going to change my, there we go. And that gives us a nice picture. So notice, where the overlap happens, that is where my solution is. Okay? So sometimes if we have like a weird graph where we have weird, like it's just way too big to graph, that type of thing, it's cool to throw it on here so you can get a nice visual of it. And then you kind of know you can kind of just sketch it and eyeball it. Okay, so we know on this guy that we're going to have this guy's probably going to come through here. Notice my second equation cuts underneath my first equation pretty quickly. Okay, so it's going to go something like, if I can get this pen to work, something like this, and the sketch is in between. Okay, something like that. But yeah, feel free to use Desmos. All right, use Desmos when you can. Continuing on. Oh, that's it. Great. Homework. Okay. Once you guys get some practice with this, you're going to be doing 1 through 15 odds and then number 25 on page 374. Make sure you label at the top of your homework that this is homework 6.6. So your name, homework 6.6, and then you can jot the assignment down. All right, guys. Thanks.